All right, so today we're diving into something that, well, sounds pretty simple on the surface. A vacuum.
Right.
But not just any vacuum. We're talking ultra-high vacuum.
Yeah.
The kind that's, well, practically space. Right here on Earth.
Exactly.
You sent over some fascinating articles on this, and I have to admit, I'm already kind of hooked by this idea of, like, mimicking space in a lab.
It's pretty mind-bending, yeah, when you think about it. I mean, we're so used to air being, well, everywhere, right?
Right.
That this idea of a space so empty it rivals the vacuum of space is, it's kind of hard to wrap your head around.
Yeah, no, totally. One article I was reading mentioned that an ultra-high vacuum is so empty that it makes a regular vacuum cleaner look like a crowded subway car.
Oh, wow.
There are still trillions of molecules bouncing around in a regular vacuum.
Right, exactly.
Fly wild.
And that's why ultra-high vacuums are so crucial for certain types of research, right?
Yeah.
I mean, imagine you're trying to study a surface at the atomic level, but you've got all these stray molecules constantly bombarding it.
Yeah.
It would be like trying to,
Oh, gosh.
it would be like trying to hear a whisper in a hurricane.
That's a great, yeah, okay, so it's all about, so ultra-high vacuum is all about getting rid of those pesky molecules, creating this environment where scientists can really zoom in on the tiniest details.
Exactly.
But how do they actually create this level of emptiness? Is it just a matter of building, like, a super-powered vacuum cleaner?
Well, it's a bit more involved than that, I'd say.
Yeah.
We're talking specialized chambers and pumps that work in stages, gradually sucking out every last trace of air and other gases. Yeah.
Wow.
And it's not just about removing the air. It's also about making sure nothing else sneaks back in.
Sneaks back in. How do you mean?
Well, even the materials that make up the chamber itself can release trapped gases over time.
Yeah.
It's a process called outgassing.
Outgassing, okay.
It's like trying to empty a leaky bucket, you know?
Yeah.
You've got to constantly be one step ahead.
So it's a constant battle against contamination. And speaking of contamination, I remember one of the articles mentioned that ultra-high vacuum is essential for achieving atomic scale clean surfaces.
Right.
What exactly does that mean?
Oh, well, think of it this way.
Okay.
Your kitchen counter might look clean to the naked eye.
Yeah.
But at the atomic level, it's a chaotic jumble of molecules, you know?
I can imagine.
Atomic scale clean means getting rid of even single molecules that cling to surfaces.
Wow.
Yeah.
So that is some serious cleaning.
Yeah.
Why is that level of cleanliness so important, though?
Well, in fields like nanotechnology, where scientists are building things atom by atom, even a single stray molecule can completely derail an experiment.
Wow.
It's like trying to build a house of cards in a windstorm.
That's a great, So by creating this ultra clean, ultra empty environment, scientists can really get down to business and manipulate matter with incredible precision.
Precisely. And that's what makes ultra-high vacuum so exciting.
Yeah.
It's not just about emptiness. It's about opening up this whole new realm of possibilities from exploring the nanoscale world to mimicking the conditions of space.
And speaking of space, I remember one of the articles highlighted the role of ultra-high vacuum in space simulations. What are scientists trying to achieve by recreating the conditions of space here on Earth?
Well, one of the biggest reasons is to test spacecraft and equipment before they're launched. Because space is a harsh environment, right? With extreme temperatures, radiation, and of course that vacuum we keep talking about. So by simulating these conditions in a lab, scientists can make sure that everything is going to work as expected before sending it millions of miles away.
That makes perfect sense. It would be a pretty expensive mistake to launch a satellite only to have it malfunction because a component couldn't handle the vacuum.
Exactly.
Are there any other reasons for simulating space here on Earth?
Absolutely. It's also about fundamental research. You know, by recreating the conditions of space in a lab, scientists can study phenomena that would be impossible to observe directly.
Oh, interesting.
For example, they can study how materials behave in a vacuum, how they interact with radiation, or even how they might have formed in the early universe.
Wow, that's fascinating. So it's not just about making sure our spacecraft work.
Yeah.
It's about pushing the boundaries of our understanding of the universe itself.
Exactly. And that's what makes ultra-high vacuum such a versatile tool.
Yeah.
It allows us to bridge the gap between
the familiar world we live in and the vast, often extreme environments that exist beyond our planet.
This is all so incredible. We've gone from picturing a superpowered vacuum cleaner to talking about mimicking the conditions of space and manipulating matter at the atomic level.
Yeah.
What other surprises does the world of ultra-high vacuum have in store for us?
Well, one area that's particularly fascinating is electron microscopy.
Okay.
Have you ever seen those incredible images?
Oh, yeah.
Of viruses or even individual atoms?
Yeah, they're incredible.
Those are made possible by electron microscopes, which use beams of electrons to see things that are far too small for traditional light microscopes.
Yes. Those images are always so mind-blowing.
I know, right?
I've always wondered how they managed to capture those images with such clarity. Is ultra-high vacuum involved somehow?
Absolutely. Here's the thing.
Okay.
Electron beams are easily scattered by air molecules.
Okay.
Got it.
So to get those super sharp images, you need to create an environment where the electrons can travel freely without bumping into anything.
That makes sense. So the ultra-high vacuum acts like a clear path
Exactly.
for the electron beams, allowing them to hit their target and create those incredibly detailed images.
Exactly. It's like creating a perfect shooting range for the electrons.
Got it.
And this has revolutionized our understanding of, well, everything.
Wow.
From the structure of materials to the behavior of biological molecules.
It's amazing to think that something as seemingly simple as removing air can have such a profound impact on our ability to see the world around us.
It really is. And that's just scratching the surface of what ultra-high vacuum technology can do.
Okay.
There are so many other applications.
Wow.
From developing new materials for solar panels to studying the fundamental properties of matter.
This is all so fascinating.
I know, right?
I feel like we've just opened the door to a whole new universe of scientific exploration.
Yeah.
But before we go any further,
I
think we need to take a closer look at how these ultra-high vacuum chambers are actually built and maintained.
Yeah.
I'm picturing something out of a sci-fi movie.
You're not far off. Building and maintaining an ultra-high vacuum chamber is a remarkable feat of engineering.
I can imagine.
It's all about creating a system that's perfectly sealed, incredibly clean, and capable of achieving pressures. Billions of times lower than the air we breathe.
Okay, I'm definitely hooked. I can't wait to learn more about the nuts and bolts of these incredible machines.
It's pretty fascinating stuff.
Yeah,
it really is.
Definitely.
But let's dive into the construction of these chambers.
Okay.
They're typically made of stainless steel, which is known for its low outgassing rate. You know, imagine trying to maintain a perfect vacuum
while your chamber walls are constantly burping out gas molecules.
that would make things pretty tricky.
It would.
So stainless steel it is.
Yeah.
But what about the pumps?
Okay.
How do they manage to suck out so much air that they create a near-perfect vacuum?
Well, it's a multi-stage process, actually.
Okay.
So first, you use mechanical pumps to remove the bulk of the air, bringing the pressure down to what we call a rough vacuum.
Okay.
But to get down to ultra-high vacuum levels, you need something more powerful.
Like what? Some kind of a super-powered vacuum cleaner from the future?
Not quite, but it's pretty close.
All right.
They use specialized pumps called turbomolecular pumps.
Turbomolecular pumps.
Which spin at incredibly high speeds.
Wow.
Literally flinging gas molecules out of the chamber.
Wow, that sounds intense. And once they've achieved this ultra-high vacuum, how do they make sure it stays that way?
Right. I imagine even the tiniest leak could ruin everything.
You're absolutely right, yeah.
Yeah.
Maintaining an ultra-high vacuum is a constant battle against leaks and contamination. The chambers are fitted with all sorts of specialized seals and gaskets to prevent air from seeping in.
And what about contamination from the inside? We talked about outgassing earlier.
Right.
Those pesky gas molecules trapped within the materials of the chamber itself.
That's a major challenge,
Yeah.
To minimize outgassing, the chambers are often baked
baked
at high temperatures before use.
Oh, wow.
It's like putting the entire chamber in an oven to drive out any lingering gas molecules.
It sounds like creating and maintaining an ultra-high vacuum environment requires an incredible level of precision.
It does.
And attention to detail.
It definitely does, yeah. It's a testament to the ingenuity and dedication of the scientists and engineers who work in this field, you know. They've had to develop incredibly sophisticated techniques and technologies to achieve these extreme conditions.
And all that effort pays off.
Right.
When you consider the amazing research being done in these chambers.
Yeah.
Speaking of research, I remember one of the articles you sent me talked about how ultra-high vacuum is revolutionizing the field of nanotechnology.
It is, yeah.
Can you tell us more about that?
Absolutely. So nanotechnology is all about manipulating matter at the atomic and molecular level, you know?
Right.
It's like building with the smallest Legos imaginable.
I can only imagine how delicate that process must be.
It is. It is.
I'm guessing that's where ultra-high vacuum comes in.
Exactly. In the nanoscale world, even the slightest contamination can completely disrupt an experiment. Right. Imagine you're trying to build a tiny circuit, atom by atom.
But a stray oxygen molecule lands on your work surface.
Right.
It could completely ruin everything.
Oh, that makes sense. Yeah. So it's like the ultra-high vacuum provides a sort of protective bubble, shielding these delicate nanostructures from any unwanted interactions with the outside world.
Exactly. It's like a clean room taken to the extreme.
I see. And this has allowed scientists to make incredible advances in nanotechnology.
It has.
From developing new materials with amazing properties to building tiny devices that could revolutionize medicine and electronics.
Absolutely, yeah.
Can you give us some specific examples of how nanotechnology is being used in these ultra-high vacuum environments?
Sure. One exciting area is the development of thin films.
Thin films.
These are incredibly thin layers of materials, often just a few atoms thick, that have unique properties not found in their bulk counterparts. Thin films, like those super thin, flexible screens I've seen on some new smartphones.
Those screens are made possible by thin film technology.
Okay.
And by using ultra-high vacuum deposition techniques.
Right.
Scientists can create even more advanced thin films with tailored properties for a wide range of applications.
What kind of applications are we talking about?
Well, for example, thin films are being used to develop more efficient solar cells, create new types of sensors, and even build tiny transistors that could lead to even faster and more powerful computers.
It sounds like thin films are going to play a major role in shaping
they are.
the future of technology.
They definitely are. And ultra-high vacuum is playing a crucial role in making those advances possible.
It's incredible to think about the level of precision involved in working with these materials. We're talking about manipulating individual atoms and molecules.
Yeah, it's like playing with nature's building blocks.
It really is. And the beauty of it is that by understanding how these building blocks interact, we can create entirely new materials and devices with properties that were unimaginable just a few decades ago.
Absolutely.
This is truly mind-blowing.
I know, it's amazing.
And I'm guessing this level of precision wouldn't be possible without the pristine, controlled environment of an ultra-high vacuum chamber.
Absolutely. It's like having a giant invisible toolkit that allows us to work with matter at the most fundamental level.
It's amazing to think that something as seemingly simple as removing air
I know, right?
can have such a profound impact on our ability to understand and manipulate the world around us.
It really is.
Are there any other examples of nanotechnology research being done in ultra-high vacuum environments?
Oh, definitely. Another exciting area is the development of nanomaterials.
Nanomaterial.
These are materials that have at least one dimension on the nanoscale, which is incredibly tiny. About a billionth of a meter.
A billionth of a meter. That's practically invisible.
It is, yeah.
What makes nanomaterials so special?
Well, because of their tiny size, nanomaterials often exhibit unique properties that differ from their bulk counterparts. For example, they might have increased strength, enhanced electrical conductivity, or even unique optical properties.
So it's like the same material.
It is, yeah.
But with superpowers.
You got it.
What are some examples of nanomaterials?
One example you've probably heard of is carbon nanotubes.
Carbon nanotubes.
These are tiny tubes of carbon atoms that are incredibly strong and lightweight. They have the potential to revolutionize, well, everything.
Wow. From
aerospace engineering to electronics.
Carbon nanotubes. I remember reading an article about them. Scientists are using them to develop everything from super strong materials to tiny sensors that can detect individual molecule.
Exactly. And ultra-high vacuum is essential for studying and manipulating these nanomaterials. It allows scientists to create and characterize them with incredible precision, ensuring that they have the desired properties for specific applications.
This is also fascinating.
I know, right?
It's like we're entering a new era of material science where the possibilities are almost limitless.
They are, yeah.
But I'm also curious about the challenges involved in working with nanomaterials. They're so tiny.
Yeah.
How do scientists even handle them?
It's definitely a challenge. Imagine trying to pick up a grain of sand with a pair of tweezers.
Yeah.
That gives you an idea of the scale we're dealing with.
I can see how that would be tricky.
It is. It is. That's why specialized tools and techniques have been developed for manipulating nanomaterials. And again, ultra-high vacuum plays a crucial role here. It provides the clean and controlled environment needed to work with these delicate structures without contaminating or damaging them.
So it's like having a giant invisible glove box that allows scientists to work with these tiny building blocks of matter without introducing any unwanted interference.
That's a great way to put it. And this ability to manipulate matter at the nanoscale is opening up a whole new world of possibilities for science and technology.
It's incredible to think that we can now create materials and devices with such precision and control. It's almost like we're becoming architects of the nanoscale world.
It really is.
And I can't imagine any of this being possible without the remarkable technology of ultra-high vacuum chambers.
You're absolutely right. Ultra-high vacuum is the foundation that allows us to explore and manipulate the nanoscale world. It's a testament to human ingenuity. And our relentless pursuit of understanding the universe around us.
Well said. This has been an incredible journey so far.
It has. It has.
We've learned about the extreme conditions of ultra-high vacuum. How these chambers are built and maintained. And how they're being used to revolutionize fields like nanotechnology.
It is, yeah.
But I have a feeling we're just scratching the surface.
I think so, too.
Of what's possible.
Yeah. Ultra-high vacuum is a key enabler for a wide range of scientific and technological advancements, from fundamental physics research to cutting-edge materials science.
Wow.
The applications are truly vast.
Speaking of fundamental research. I remember one of the articles you sent me mentioned that ultra-high vacuum is being used to study the origins of the universe.
It is, yeah. That's amazing, isn't it?
How is that even possible?
Well, it might sound counterintuitive.
Yeah.
But by recreating the extreme conditions of space in a lab, scientists can actually gain insights into the processes that occurred during the Big Bang and the formation of the early universe.
Wow, that's mind-boggling. So by studying the behavior of matter in an ultra-high vacuum, scientists can actually peer back in time.
In a way, yeah.
And unravel the mysteries of the cosmos.
Well, it's not quite time travel, but it's the closest we can get, right?
I guess so.
By carefully controlling the environment and observing how particles interact under these extreme conditions, scientists can glean valuable information about the fundamental laws of physics that govern the universe.
This is absolutely fascinating.
It is, yeah.
I never would have guessed that something as seemingly simple as a vacuum could have such profound implications for our understanding of the universe.
It really is, yeah.
It's a testament to the power of scientific inquiry and the importance of pushing the boundaries of what's possible.
Absolutely.
Okay, my mind is officially blown.
I know, right? It's amazing stuff.
But before we dive into the mysteries of the cosmos, I think we need to take a moment to appreciate the incredible engineering behind these ultra-high vacuum chambers. I mean, creating and maintaining a near-perfect vacuum is no small feat.
Absolutely. Building and operating these chambers is a fascinating story in itself.
Yeah, I can imagine.
It requires a deep understanding of materials science, vacuum technology, and precision engineering.
Okay, I'm definitely hooked.
Good, good.
Tell us more about how these technological marvels are brought to life.
All right, so first of all, you need to choose the right materials for the job, as we mentioned earlier. Stainless steel is a popular choice because it's strong, durable, and has a low outgassing rate.
Right, we don't want our chambers burping out gas molecules.
Exactly.
But stainless steel is just the beginning, right?
It is, yeah.
What other materials and components go into building these chambers?
Well, you also need specialized seals and gaskets to prevent any leaks.
Right.
These seals are often made of materials like copper, Viton, or even gold.
Gold.
Depending on the specific requirements of the experiment.
Gold seals. That sounds fancy.
Well, it's all about choosing the right material for the job.
Right.
Gold is actually a very good sealant.
Oh, okay.
Because it's chemically inert and can withstand high temperatures.
So it's not just about aesthetics.
No, not at all.
It's about functionality.
Exactly. Every component of an ultra-high vacuum chamber is carefully selected to ensure that it can withstand the extreme conditions and maintain the integrity of the vacuum.
This is like a high-stakes game of molecular hide-and-seek.
Yeah, it kind of...
Every potential leak or source of contamination has to be anticipated and addressed.
You're exactly right. It's a constant battle against the relentless influx of molecules from the outside world.
So building an ultra-high vacuum chamber is like creating a fortress against the invisible forces of nature.
That's a great analogy.
Yeah.
It requires meticulous planning, precise engineering, and a deep understanding of the fundamental principles of vacuum science.
It's truly a remarkable feat of human ingenuity. But once you've built this molecular fortress, how do you actually create the vacuum inside?
Well, that's where the pumps come in, as we mentioned earlier. It's a multi-stage process. You start with mechanical pumps to remove the bulk of the air. Then use specialized high vacuum pumps, like turbomolecular pumps, to achieve those ultra-low pressures.
Those turbomolecular pumps sound pretty impressive.
They are, yeah.
I remember you mentioned they spin. At incredibly high speeds to fling out gas molecules.
Exactly.
How fast are we talking?
Tens of thousands of revolutions per minute.
Wow. That's some serious spinning.
It is.
And once you've achieved this ultra-high vacuum, how do you make sure it stays that way? I imagine. The tiniest leak could ruin everything.
You're absolutely right, yeah. Maintaining an ultra-high vacuum is a constant battle against leaks and contamination. The chambers are constantly monitored for any pressure changes, and specialized leak detectors are used to pinpoint any potential sources of contamination.
It sounds like a never-ending game of whack-a-mole with molecules.
It can definitely feel that way sometimes, yeah. But it's a challenge that scientists and engineers have embraced, developing ever more sophisticated techniques and technologies to push the boundaries of vacuum science.
It's inspiring to see how far we've come in our ability to control and manipulate.
It really is, yeah.
The world around us.
It is.
And it all starts with something as seemingly simple as a vacuum.
It really is a testament to the power of human curiosity and our desire to understand the universe around us.
Well said. This deep dive into ultra-high vacuum has been an incredible journey so far.
Sure, it has. It has.
We've learned about the extreme conditions of these chambers,
the
incredible engineering behind their construction, and the amazing research that's being done within their pristine, airless confines.
It's amazing stuff, isn't it?
But I have a feeling we're just getting started.
I think you're right, yeah.
What other wonders await us in this airless realm?
Well, one area that I find particularly fascinating is the use of ultra-high vacuum in space simulation.
Space simulation.
As we touched on earlier. By recreating the conditions of space here on Earth, scientists can test spacecraft and equipment before they're launched
right
into the harsh environment of space.
That makes perfect sense. It's like a dress rehearsal for spaceflight.
Exactly. And it's not just about testing equipment.
Okay.
Space simulation chambers also allow scientists to study the effects of space on materials, biological systems,
interesting,
and even fundamental physics.
Wow, it sounds like space simulation chambers are like mini universes.
Yeah, kind of.
Where scientists can conduct all sorts of incredible experiments.
You could say that. They're like giant playgrounds.
Wow.
For scientists who are trying to understand the universe and our place in it.
I'm definitely intrigued. Can you give us some specific examples?
Sure.
Of how space simulation chambers are being used to advance our understanding of the cosmos?
Absolutely. One exciting area of research is the study of cosmic rays.
Cosmic rays?
These are high-energy particles that bombard Earth from space.
Cosmic rays. I've heard of them.
Yeah.
They're like tiny messengers from the depths of space.
Yeah.
Carrying information about distant stars and galaxies.
Exactly. And by studying them in a controlled environment, scientists can learn more about the processes that create these high-energy particles and the environments they travel through.
But how do you study cosmic rays in a lab? Don't they need the vastness of space? To travel at those incredible speeds?
That's where space simulation chambers come in. By creating an ultra-high vacuum and using powerful magnets to accelerate particles. Scientists can create their own mini cosmic rays right here on Earth.
That's amazing. So it's like having a cosmic ray particle accelerator in a lab.
You could say that. It allows scientists to study these high-energy particles in unprecedented detail.
Wow.
Revealing new insights into the fundamental nature of matter and energy.
This is incredible. It's like we're bringing the mysteries of the cosmos down to Earth.
Yeah.
Where we can study them up close and personal.
Exactly.
It's a testament to the power of human ingenuity.
It is, yeah.
And our insatiable curiosity about the universe around us.
Absolutely.
Well said. This deep dive into ultra-high vacuum has taken us on an incredible journey so far.
It has.
From the nanoscale world to the vast expanse of space.
Yeah.
But I have a feeling we're just getting started.
I think you're right, yeah.
What other wonders await us in this airless realm?
Well, one area that I find particularly exciting is the use of ultra-high vacuum in the development of new materials.
New materials.
As we touched on earlier. The pristine environment of an ultra-high vacuum chamber allows scientists to synthesize and characterize materials with incredible precision.
I remember we talked about thin films and nanomaterials earlier.
Yes, did, yeah.
Are there any other types of materials being developed in ultra-high vacuum environment?
Oh, absolutely. One area that's generating a lot of excitement is the development of two-dimensional materials.
Two-dimensional materials.
These are materials that are just one atom thick.
One atom thick?
Yeah.
That's thinner than a human hair.
It is, yeah.
What makes these two-dimensional materials so special?
Well, because of their unique structure. Two-dimensional materials exhibit remarkable properties not found in their bulk counterparts. For example, graphene, a single layer of carbon atoms arranged in a honeycomb lattice is incredibly strong, lightweight, and conducts electricity better than copper.
Graphene, I've heard of that.
Yeah.
It's being touted as a wonder material. With the potential to revolutionize everything.
It is, yeah.
From electronics to energy storage.
Exactly. And ultra-high vacuum is essential for synthesizing and characterizing these materials. It provides the clean, controlled environment needed to create these delicate atomic structures without introducing any defects or impurities.
So it's like having a molecular drawing board.
Yeah, it kind of is.
Where scientists can assemble these two-dimensional materials, atom by atom.
Exactly.
And these molecular drawings have the potential to transform the world around us.
They do, yeah.
It's amazing to think that we can now create...
I know, it's incredible.
...materials that are just one atom thick. What other types of two-dimensional materials are scientists working with?
Well, in addition to graphene, there's a whole family of two-dimensional materials, each with its own unique properties. for example.
Okay.
There's molybdenum disulfide,
Okay.
which is a semiconductor that could be used to create more efficient solar cells.
Right.
And hexagonal boron nitride.
Wow. That's a mouthful.
It is.
Okay.
Which is an insulator that could be used to create new types of transistors.
It sounds like we're entering a new era of material science.
It does, doesn't it?
Where the possibilities are truly limitless.
It seems that way, yeah.
And it all starts with something as seemingly simple as a vacuum.
You're absolutely right.
Right.
The ability to create and control ultra-high vacuum environments has revolutionized our understanding of the world around us.
Right.
From the tiniest atoms to the vast expanse of space.
It's a testament to human ingenuity.
It is.
And our insatiable curiosity about the universe.
Absolutely.
This deep dive into ultra-high vacuum has been an incredible journey.
It has. It has.
We've learned about the extreme conditions of these chambers,
right,
the incredible engineering behind their construction, and the groundbreaking research that's being done within their pristine, airless confines.
It really is amazing, isn't it?
But I'm curious, what does the future hold for ultra-high vacuum technology?
Well, as our understanding of the universe continues to expand, so too will the applications.
So we've explored the nanoscale, ventured into the realm of space simulation, and even glimpsed the future of quantum technologies.
Yeah.
But there's one final frontier I want to touch on before we wrap up our deep dive into ultra-high vacuum. Its role in the quest for clean energy.
Oh, absolutely. That's a crucial area where ultra-high vacuum is making a huge difference.
Yeah.
Think about it.
Okay.
Creating efficient solar cells. Powerful batteries.
Right.
Even new types of fuel cells. All of these technologies depend on understanding and manipulating materials at their most fundamental level.
And that's where ultra-high vacuum comes in, right?
Exactly.
Creating that pristine environment where scientists can really tinker with the building blocks of matter.
Yeah, it's like, take solar cells, for example.
Okay.
Efficiency is key.
Right.
And that often comes down to the purity and structure of the materials used with ultra-high vacuum deposition techniques. Scientists can lay down incredibly thin, uniform layers of materials, ensuring optimal performance.
I'm picturing those thin films we talked about earlier.
Right, exactly.
But now tailored for capturing sunlight with incredible efficiency. Are we talking about any specific types of solar cells that benefit from this?
There are a few that come to mind. Perovskite solar cells.
Perovskite solar cells.
For example, are showing a lot of promise.
Okay.
And their fabrication often involves ultra-high vacuum processes to control the delicate crystal structure.
Perovskite solar cells, that's a new one for me.
Yeah.
I'll have to do some reading on those.
They're pretty fascinating.
But it sounds like ultra-high vacuum is helping to push solar cell technology forward.
It is. It is.
In some really exciting ways.
It definitely is.
Yeah, and it's not just solar.
Right.
High-capacity batteries are another area where ultra-high vacuum is essential.
Absolutely.
Researchers are exploring all sorts of exotic new materials for batteries, trying to cram more energy storage into smaller spaces.
Exactly.
So we're talking about the batteries that will power our electric cars, our phones, maybe even our homes.
Yeah, absolutely.
But how does ultra-high vacuum fit into the picture?
Well, creating these advanced battery materials often involves layering different elements with atomic precision.
Right.
And sometimes these elements are highly reactive.
Oh, wow. Okay.
So ultra-high vacuum provides the controlled environment needed to prevent unwanted reactions and ensure the materials perform as intended.
It's amazing how something as seemingly simple as removing air
I know, right?
can be so crucial for building the technologies of the future.
It is.
It's like creating a blank canvas for scientific innovation.
It really is. And as we move towards a more sustainable future, I think ultra-high vacuum technology is going to play an even bigger role. We've touched on energy, but there are also applications in fields like catalysis. Which is essential for developing cleaner industrial processes.
Catalysis, that rings a bell.
Yeah.
It's about speeding up chemical reactions,
Exactly.
right? Like those catalytic converters in cars that help clean up exhaust fumes.
Exactly. And researchers are using ultra-high vacuum techniques to study catalysts at the atomic level, try and understand how they work, and design even better ones.
So from clean energy to clean industry.
Yeah.
It sounds like ultra-high vacuum is a key ingredient.
It is.
In building a more sustainable future.
I absolutely agree.
Yeah.
It might seem like an esoteric technology, but its impact is far-reaching.
Well, this deep dive has certainly opened my eyes to the importance of ultra-high vacuum.
Yeah.
It's a technology that's often hidden from view.
It is.
But it's quietly shaping the world around us in profound ways.
It really is.
Before we wrap up,
I
have to ask, what's the one thing you want our listeners to take away from our exploration of ultra-high vacuum?
I think it's the realization that even something as seemingly empty as a vacuum can be a wellspring of innovation and discovery. Sometimes taking things away, stripping things down to their essence, can reveal the most amazing possibilities.
That's a great takeaway. It's a reminder that the biggest breakthroughs often come from the most unexpected places.
They do.
And sometimes the most important ingredient in scientific progress is the absence of something we take for granted, like air.
It's been a pleasure sharing my passion for ultra-high vacuum.
The pleasure was all mine.
With you and our listeners today.
This deep dive has been an incredible journey.
It has. It has.
And I encourage our listeners to keep exploring this fascinating world of science and technology.
Absolutely.
There's always something new to discover, even in seemingly empty spaces.
Couldn't agree more.
I think that's a great place to leave it.
I think so too.
Thank you so much for joining me today.
My pleasure.
And thank you to all of our listeners for tuning in.